Welcome to A-Level and AP Physics. In today's lesson, we will discuss some very important past paper questions on mechanics from Specimen Paper 1 for 2022. For question number 15, it is given to us a metal block has a mass of 750 grams. Magnesium makes up 60% of the mass and the remaining 40% is copper. Density of the magnesium is given and this is equal to 1.7 gram per cubic centimeter, and density of copper is also given, that is equal to 9.0 grams per cubic centimeters. We need to find out what is density of the block. Now, first of all, let's try to understand how we can find out density of the block. So simply I will write down here density of block. In order to find density of block, we need mass of the block, means the total mass of the block, and this one we have to divide by volume of the block. Very simple concept. Density is equal to mass over volume. But for this question, mass of the block is given, so simply we can write down mass of the block is 750 grams. We will use here grams because our answer has to be in grams per cubic centimeter. So for the mass, we can use unit grams. And this one has to be divided by volume of the block. Now, this is the point we need to find out. We need to find out volume of the block. So how we can find out volume of the block? In order to find volume of the block, we need to understand volume of block, in fact, is equal to volume of copper. We can write down is equal to volume of copper plus is equal to volume of magnesium. I will be writing here Mg, the symbol for magnesium. Now, how we can find out volume? Volume will be equal to mass. For example, if you need to find volume of copper, we will divide mass of copper divided by density of copper. So let's write down here mass of copper. We can simply say volume is equal to mass of copper divided by density of copper plus volume of magnesium. So this will be equal to mass of magnesium divided by density of magnesium. Now simply we need to plug in values. Mass of copper, it is given to us 40% masses, means 40% of the mass of the block is mass of copper. So it simply means that 0.40 means the 40% of the mass of the block is mass of copper. So that's the reason you need to multiply with 0.40. And this one we have to divide by the density of copper. Density of copper is 9.0 grams per cubic centimeters. And the mass of magnesium. Magnesium makes up 60% of the total mass. Means 60% of the mass of the block is mass of magnesium. So we will be multiplying total mass with 0.60. So this is multiplied by 750 divided by density of magnesium, that is given here. And so this is density of magnesium. So we can simply divide this one by 1.7. Now if we solve this one, we will get this is our value of volume of copper. And if we solve this one for volume of magnesium will be 264.7. So the total volume we can find from here means the volume of the block, that will be 298.0 cubic centimeters. So this is cubic centimeters. Now simply we have to divide here. So this is 298.0 cubic centimeters. You can write down the unit here. Now if we solve for density of the block in this case will be equal to 2.51 grams per cubic centimeters. Up to 2SF we can simply write down this is 2.5 grams per cubic centimeters. So this is our final answer. So option A is correct for this question. So you need to understand the approach. It's very important. The method, the way you approach problem is very important. For question number 16, it is given to us a man climbs slowly at a steady speed to the top of a ladder. What is the main energy transfer taking place for the man as he climbs? For this question, it is given to us the person is climbing at a steady speed. So if the speed is steady, it means speed is constant, means V is constant. So first thing thing we need to understand is that steady speed means that speed is constant. If the speed is constant, it means that the change in kinetic energy is equal to zero. It simply means that kinetic energy initial, kinetic energy is equal to kinetic energy final. Means no change in kinetic energy. Let's try to understand this one with the help of these steps. So I will draw these steps. So you can imagine that this is the ladder. So you can imagine it like this. Now imagine that person started from this point. So this is the base. At this point, person has certain speed. Let's say speed of the person is u at this point. The speed of the person is u, and the person is walking this way. And when person reaches the top of the ladder, at this point, this is the top. Speed of the person is still u. So if you want to write down kinetic energy at this point, kinetic energy initial, you can say this is equal to 1/2 mu square. M is the mass of the person. Let's take the base of this ladder as our reference line, or you can say reference level. And at this point, we are assuming that gravitational potential energy of the person is equal to 0. So the initial GPE of the person is equal to 0. And when person is at the top of the ladder, we can also write down the total energy of this person. So we can say E total will be equal to kinetic energy final plus mgh. Or simply we can say kinetic energy final is equal to kinetic energy initial plus this is mgh. Now if we compare energy of the person at the base and at the top, you can simply say that energy of the person has been increased. Means person has gained gravitational potential energy, but the kinetic energy is the same. So kinetic energy at the base and at top is the same, but gravitational potential energy of the person has been increased. So this increase in gravitational potential energy actually is coming from the chemical energy inside the body of the person. So this increase in GPE is coming from chemical energy inside the body of the person. So if this person climbs many times to the top of the ladder, this person will get tired because this person is consuming chemical energy. In this case, simply we can say that the person is converting chemical energy into GPE by climbing this ladder. And that's the point we need to understand. So the answer for this question is chemical potential energy to GPE, gravitational potential energy. So in this case, simply, very simple question. Simply you need to understand GPE has been increased. So in this case, chemical energy of the person has decreased and that chemical energy has been converted into GPE. So the answer is A. For question number 17, it is given to us a bead is released from rest at point P and slides along a wire as shown in figure. So this is the bead. We release this bead from point P. At this point, the bead was at rest. So the initial speed of this bead is equal to 0. We can also say its initial kinetic energy is also equal to 0. It is also given to us at point Q, the speed of the bead is 1.4 meters per second. And the height of the bead, we can say this is h. Height of the bead, this is also given, that is 40 centimeters. We can say this is at 1 because this h is already here. So we can say this is h1. It is given to us in this case air resistance and friction on the wire are negligible. So friction and air resistance are negligible. So it simply means that mechanical energy is conserved. So this simply tells us that in this case, mechanical energy is conserved. So we can simply say mechanical energy is conserved. Very important point. Mechanical energy is conserved. So later I will explain what exactly is mechanical energy. So mechanical energy is conserved for this question. We need to find out what is the height h from which the bead is released. Simply we need to find out what is value of this h. So simply we will use conservation of mechanical energy. And mechanical energy is equal to the sum of kinetic energy and gravitational potential energy. Sum of these two energies is equal to mechanical energy. So simply we can say in this case mechanical energy is conserved. So we will say kinetic energy initial plus GPE initial in this case has to be equal to kinetic energy final plus GPE final. Kinetic energy initial is equal to 0. So simply we can say this is equal to 0. And imagine that mass of this speed is m. So we can simply say this is mgh. Kinetic energy final will be equal to 1/2 mv square plus mgh1. So h1 is this height. Now simply we can plug in values and we can find out our final answer. One thing you can see here, m is common, so mass we can simply cancel. So this m we can cancel, so all these m we can cancel. We left with h, so we need to find out h. So this simply means this is v squared divided by 2 plus we have this is gh1 and this whole is divided by g. If we further we want to simplify this, we can write down this will be equal to v squared divided by 2g plus we have h1. Now simply we need to plug in values. So v squared I will be writing here, v squared means the speed at this point we have that is equal to 1.4. So this is 1.4 squared divided by 2g, 9.81 you have to use at ES level, plus h1 is 40 centimeters. So simply we can say this is 0.4 meters. Now if we solve this one, our final answer will be 0.49 meters. So C is the best possible answer. For question number 18, it is given to us a mass is raised vertically. In time t, the increase in its gravitational potential energy is EP and increase in its kinetic energy is EK. What is the average power input to the mass? So first thing we need to understand is what is average power input. So I will write down average power input. That is equal to the total change in energy of the mass divided by time taken. Now imagine that we have the mass here. Let's say this mass is placed on the ground. Simply you can imagine like this. This has mass. Here it has kinetic energy initial, that is equal to 0, and it has gravitational potential energy initial, that is also equal to 0. Now we raise this mass vertically to certain height. At this certain height, the kinetic energy of this mass is EK plus it has also EP. So this is the total energy of this mass at this point. So we can say this is ET, total energy of the mass, and this is also equal to the total change in energy of this mass. So we can say this is delta ET. So here 0 and the final one is EK plus EP. This is equal to the change in energy of the mass. So the power is energy transfer over time, or you can simply say the change in energy over time. So change in energy is EK plus EP, means mass has gained this much energy in this given time. So the answer for this question is D. Very straightforward question. Answer is D. For question number 19, it is given to us water flows from a lake into a turbine that is at a vertical distance of 90 meters below the lake as shown in this figure. The mass flow rate of the water is given, that is equal to 2400 kilograms per minute, and the efficiency of the turbine is given, that is 75%. We need to find out what is output power of the turbine. So very straightforward question. So simply we will start from percentage efficiency. So I will be writing here percentage efficiency. This is equal to useful power output. So useful P out. So simply we can say useful P out divided by total P in. For this question we need to find out useful power output. So simply we will write on here useful power output, or simply we can say P out. That one will be equal to the percentage efficiency. Here we have percentage efficiency times E in, and then we can calculate value of useful P out. So I will be writing here P out simply here. So the P out is equal to P in. First of all, we have to multiply with percentage. So this is 75%. So it simply means that 75 divided by 100 multiplied by P in, and P in is mg delta H over T. But in this question, M over T is given. So let me write on here. I can say this is 0.75, but M over T is given to us. M over T. We have to use SI unit. So we have to divide by 60. Means 1 minute has 60 seconds. So this is M over T. And G is 9.81 and the height is 90 meters. So if we solve this, our final answer should be 26 kilowatts. So this will be our final answer. So for this question, final answer is A. So simply you can also understand here. So here we have P in. So this is P in. So this turbine has certain efficiency, and here is P out. Question is asking us to calculate P out. For question number 20, it is given to us a wire of diameter small d and length L hangs vertically from a fixed point. The wire is extended by hanging a mass capital M on its end. The Young's modulus of the wire is capital E. Acceleration of free fall is g. We need to find out which equation is used to determine the extension x of the wire. So we will start by sketching, so you can get the clear picture of this question. Imagine that this is a fixed point and the wire is hanging from this fixed point, and there is a mass that is attached at the end of this wire, and the mass is capital M. The length of this wire is given, that is L. Young's modulus of this wire is given, that is capital E. Diameter of the wire is given, that is E. We will start from stress first of all. Stress is equal to the force exerted on the wire. We can say the tension in the wire. In this case, we can write down simply F over A. F is the tension in the wire. R is the force acting on this wire. So let me draw the free body diagram here. So if you look at this mass, the force acting down, this is the mg, and the tension in the wire is up. So tension in the wire in this case has to be equal to mg because this wire is not moving. So the tension is equal to mg. So simply we can write down tension in the wire is mg divided by cross-sectional area of the material. As this wire is a solid wire, so cross-sectional area of this one is pi by 4 d squared. Now if we simplify this, we can write down stress is equal to 4 mg divided by pi d squared. Now we need to find the relationship between Young's modulus, stress and strain. So simply we can say Young's modulus is equal to stress over strain, but strain is equal to extension over L naught. Extension in this case is X and the length of the wire is L. So this is strain. Now simply we need to plug in values. For stress we can write down this is 4 mg divided by pi d squared, and this whole has to be divided by strain, and strain is simply X over L. Now if we simplify this one, we can write down this is 4 mg. This L we will multiply here, and this will be divided by X pi d squared times E. So this is how we can simplify. Now we need to find out value of X, means extension. So that will be equal to 4 mg times L divided by E times pi d squared. So the answer for this question is this. So this is our final answer.